right. So my friends, I want to make sure. I want to make sure we're good. So tomorrow, which is Friday, we will have the multiple choice portion of the chapter 2 test. Right? Right? Okay. I heard someone say he said chapter 2 test. I'm like, uh-oh, was it not chapter 2? All right. Now, I have heard, and I support this, but I don't know. Monday, I was planning the short answer portion of the test, but I heard that there's the opportunity for some students that might not be here, which might mean Tuesday might be that. Okay? All right.
I don't know, man. Everyone might be sick by next week.
Could be. I mean, you might eat too much chocolate on.
That's what's going to be.
Well, there's a big sickness going on during break.
There is.
And some kids are getting sick now.
So,
Mr. Stirrup, do you think that the snake is beautiful?
sure. All right. So I think my friends, hush. I think my stuff is right now. I have to warn you, and I'm not warning you to scare you. I'm just warning you. This is a bit longer, but I truly feel that of the majority of the questions that are on there, I'd say like 90% of them, you're like, oh my gosh, totally got it. Now, there is a question that is on there that you do have some sort of scatter plot that's given, okay? And they tell you, and they'll say, hey, the equation of this is, I'm just going to make up values. So they'll say something like that, okay? And then they'll actually say, hey, you have an R value of 0.82. So 0.82, pretty good. That's our equation. But then it gets a little tougher. Now, these are all labeled. Hopefully we can see them. I was able to see them this morning. There's one thing that they say, and this is for a multiple amount of problems, where you're looking at this type of thing, it's given to you, you're not having to generate it. But some of the questions might say, which points, and they'll say it like this. So does that mean there's more than one answer on a multiple choice? Or could there be?
Maybe.
Yeah. So, and then they might say, here's point A, here's point B, here's point C, and then here's point D. So which of those points would definitely influence our line of best fit? A, I guarantee. So A is going to move it upward, right? A would move our graph upward. B, what would B do to it? Yeah, it would change our line to move down a little bit. So A and B definitely are going to influence it. Would C influence it? A little bit. I like that. Okay, so, but does everyone feel pretty comfortable that D is not going to really change our line of best fit? I mean, it might like, oh, look, 7 decimals out, it changed the 7 to an 8. Oh, changed the world. So point D is definitely not going to influence it. So please be aware that when you come across a question that has this type of thing, there are multiple answers. So almost every question on the test has one answer, which makes it worth 1 point. This type of question, because A, B, and C would all influence it, this would be a 3-point question. Okay? So you definitely want to, kind of realize if it says points, and it might have points with the S in parentheses, or it might just say points. So there is very possible. I think there's 2 questions that have 3 answers each, I believe. Okay? Now, there's one question that it's kind of the same idea, but it might have an R value of 0.462. Okay? So there's two words that they use about the correlation. They say there's a positive correlation, which you all agree with because it's a positive 0.412. Or, yeah, 0.412, or 0.462, excuse me. So this would definitely have a positive correlation. But then they use two words, and when I looked at the two words, I almost think they're adjectives of each other. So, and I'm not trying to say this I'm not trying to guide you on it, but the main thing, when you get to a question that gives you some R value, and I don't remember what the exact R value is, but it's kind of, in the cruddy range. I look at that as a 46.2% on a test, which I think is cruddy. But the two words that they use, I would take either of the answers. Okay, so the main thing you're looking for is you want to say positive correlation. Don't have negative correlation. If you get negative correlation, you get it wrong. But it's one answer or the other. So I just want you to be cautious on it and just realize I'm not a big fan. So like A, B, C, and D, this would say negative correlation, positive, or something. I don't remember the exact order of it. But the main thing that I need you to focus on is I think either of these answers are correct. Don't choose both. I mean, if you choose both, I'm not going to mark you wrong, but I'm not going to make it worth 2 points. So just be aware if it comes across an R value. If this R value is negative, then you know it's either A or B because it's going to be the negative correlation. So I just want to make sure you feel comfortable with that. Does that make sense?
What does it mean when you say A negative?
I'm sorry?
What does it mean when you say like A negative?
Oh, negative correlation. A negative correlation would just be this.
Yeah, I know what it is, but are you just saying if the correlation is negative, then you choose it?
Yes. And the thing is, it's not just one word. It'll say like negative something, but I think that the two words that they use for, let's say it's positive correlation. I think the two words that they use, they're adjectives of each other. So I think they're the same thing.
Oh.
So what I'm trying to mean is, if you can decipher that it's positive correlation, don't sit there and go, gosh, and it's like saying it's red orange or orange red. Like in the Crayolas. You remember those? Well, I didn't catch it originally, so I'm just trying to point out that there are two answers I would definitely accept. Make sure that you pick one or the other if it's positive correlation, or one or the other if it's negative correlation. Because I think the words are so very closely related. And there's a lot of argument that can go into it, which is fine. So I would just take either of the answers. And of course, you circle both, then you're guaranteed to get it. But if it was a positive correlation, you say it's negative, and you say, cool, it's one of the negatives. Well, you have to decipher. Negative correlation means it has a negative slope. Positive correlation means that it's positive slope. So just be aware of that. And then there are two questions on there that I am not a fan of, so we're just going to skip. Here's the nice thing. You skip it. I'll tell you which ones that is skip when we get to it. Rather than changing my rubric, if the thing's worth 45 points because there's 45 different answers, 2 of them I'm giving to you for free because I don't like the questions. So we're just inadvertently skipping them. So some other things that I want to make sure that we feel good about. Let's say we have a residual graph. Okay? Now, does a residual graph necessarily show our line of best fit? So if we have a line of best fit, which is this, the residual graph does not look like this. This is not the residual. The residual graph is going to look like this. So it looks like that. And there's not a line of best fit that's drawn. So what does the residual really show us on a residual graph? What it shows you is, let's say, gotta do it on here. Let's say, and I'm just going to make this up off the cuff. So that point might refer to this point here. Okay, and I might be totally off. So what does it really mean? Well, I have a positive distance here that's above the line of best fit, right? So that distance there is this distance here. So let's say this came to a distance, let's say this point here is the point 5, 10, but this point here is 5, 12. So the line of best fit would show a different point. We underestimated with our line of best fit for that particular value. So what's the residual value between these 2 points? Positive or negative 2? And how did I get positive or negative 2? Well, this is where my point, subtract my graph. So my point is 12, and you're looking at the y value on it, minus my y value on my graph. So I get a residual of 2. So that means that this distance right here would be 2 above 0. Okay? So let's say there's a 2 right there. Okay? That's really what it means. Now, if I picked another point, let's say I picked this point right here, that might correspond to this point right here. And I'm just making this up off the cuff. This is not an actual thing. But then I also have a distance there. So what do you know about this R value versus the other R value, and why? What was the R value up here? It was a positive 2. What was this R value going to be here? Which we can guarantee that R value is going to be regardless of a number. Huh? It's negative. So that would have a negative residual. The reason it has a negative residual is it would be an underestimate. So our line of best fit overestimated what the actual point was. So the points you get from your data table, x1, y1, okay, or L1, L2, whatever you're doing. So when you make your line of best fit, the residual value is negative if it falls underneath it. That means that you made less. It's negative distance. So this might have a distance of negative 1.5. Great, now I came up with a decimal, which means that the point here, so the distance of this point here, looking at the y values, would have a value of negative 1.5, which would be the residual. Okay? So those are just things to be cautious about. Yeah?
It's always observed minus predicted.
Observed minus predicted. So the point minus the graph. Observed point minus graph. Yes.
Okay, and then is y hat predicted?
Y hat just means that we're dealing with data.
So that's the observed value, and the regular y is the predicted value.
Yeah. So you have the point and the graph. The graph is your linear equation. Okay. So that takes me to the next thing. So let's just come up with. We came up with y hat is equal to 2.5 minus 3x. And I don't care what we're saying, but let's say that was what our line of best fit. And then there's some data table that we have, so we have all these values that are plugged in. But let's say we have okay, I'm just trying to think. 30, 10. 10 negative 20. Okay? So this point was plotted along with all the other points. Okay? So I know the point 10 negative 20 was a data point. Okay? But let's say I'm asking, what's the residual at 10? So what should I do with that 10 in order to figure it out? Yeah, plug it in right there. So I'm going to get 2.5 minus 3 times 10. So that's 2.5 minus 30, which is negative 27.5. Okay? Now, it gets kind of awkward to think about that. So realize I'm talking about two data points, or I'm talking about something that's happening. This is happening on the graph, so that on the line of best fit. This was just a data point. So if you kind of think about what this is doing, this is some sort of linear equation like this. It's negative because it has a negative slope. You know, this value right here would be 0, 2.5. Okay, the Y-intercept. So then I know that at 10, I know I have it negative. Let's see. Let's say this is negative 30. So at 10, come on, strip. You don't have enough room. This data point, or this is because of my line of best fit, and I know it doesn't match up with our line because I have a negative value. That point is this. But then if I took this value, 10, negative 20, so negative 20 would be like here, because our x-axis is up there. I am being sloppy, and I apologize. Okay, so there is a distance between these 2 points. So what I'm going to do is, one, my data point happened above my line of best fit. Agreed? Even though it's a negative number. And I don't have a negative number on it. It's going to be a positive number. So was this an overestimate based on our line of best fit? I think so. It's above it. So what I'm going to do is I'm going to say, okay, what is my distance of my R value? Well, from 20 to 27.5 is 7.5. Is it supposed to be a positive or a negative 7.5 as far as that distance goes? Well, it's above. It has to be positive because it was above our graph or our line of best fit. I swear I have like multiple things and I have way too much I'm putting on there. So I'm just trying to point out, and again, when I make problems up off the cuff, they don't come out as pretty. On the test, they're a lot prettier. They're not going to be like some weird, obscure negative values. Okay? So again, on this, don't panic tomorrow on this quiz or this test. Yes, it's going to feel like, oh my God, there's an ungodly amount of questions. There is. There's like, I think it's worth 45 points. 6 of the points come because 2 of the questions have 3 answers. So it's like 38, 39 questions that you have to answer. So it's a front, back, front, back, front, back, or something like that. It's ridiculous in length. But honestly, I said the whole front page, if you have been here paying somewhat attention, you're going to get the front page done in about a minute. And then the second page will probably take you a minute and a half. Third page will take you 2 minutes. I mean, but if you don't have any clue of this, or you didn't put anything on a note card, it's going to be a little tougher. It's like, oh, how do you do this? Now, you remember, I said one of the questions, and I'll actually, when we get to it, I'll say which question it is, where, you know, you have positive, positive, negative, negative for the correlation. It's either both positives or both negatives. It's not because two answers are right. It's just because I truly feel you can make an argument for both. Because I think they're really, the words that they use, and I'm not an English major, but I think the words they use are very close adjectives to each other. Okay, so I'm looking at page 179, which is 214. Or, yeah, 2-14, so page 179. And there's negative association. Oh. This is just a secondary question. This is a residual graph. What does that really mean? Does it mean that we have a parabola for our graph? No, it's a residual. So basically, values from here to the left and values from here to the right have R values that are negative. And then in between here has an R value that's positive. Okay? It doesn't mean that we don't have a good line of best fit. I mean, a lot of times in statistics, you want to see some sort of pattern when you plot your data. When you plot your residual, you don't always want to see a pattern. So there might be an argument on this one saying, what are we comparing? What does this really make sense that, to the left of a certain number and to the right of a certain number that we'd have negative values, but in between two numbers, everything would be positive? I mean, honestly, you want the residual graph to have above and below. You don't want to see a specified pattern. And this appears to be a pattern. But it might ask you something saying if this is a point, let's say this is the point 10 comma 0, and this is the point 20 comma 0. There's information you could say, hey, from 0 to 10 this is taking place, from 10 to 20 something's taking place, 20 to whatever something else is taking place. So just be cautious if you see a pattern on a residual graph. It should not have a pattern. It should be something kind of goofy. And again, you might see a graph like this. This is actual data. Is there a line of best fit? A line of best fit might be like this. So is there something else that might work? I would say you might want to realize that this could be some sort of quadratic versus a line. Okay, the quadratic will give you R squared values. The line of best fit will give you R squared as well, but this also gives you R. So if I only have an R squared value, that just means you're talking about a two-dimensional analysis of your data. The R value is the one dimension. So an R value is like, that's an R value. An R squared value would be this. And there's no difference between a lowercase r and a capital R in Stirrup's world. So does that make sense? So R squared is a two-dimensional. You have a vertical and a horizontal square, whereas an R value is just a vertical amount. Let's say we have a graph that does this. We have a line of best fit. Let's say this is number 10, comma, we pick that, we can say that that's the point 10 comma 5. Yes or no? Could I have if 10 is my furthest to my right point, but I draw this line of best fit that goes on forever, could I have 30 comma something? No is correct, but why would it be? It's extrapolation. We don't trust it. We're not going to trust extrapolation. Okay? What about this point right here? The Y-intercept. Trust it or not? Well, this is my lowest data point, so it's also extrapolation. Okay? Now, there's times that they might say, hey, what does the Y-intercept mean in the context of this problem? So let's say we are doing let's go with 2000, 2005, 2010, 2020, 2015, 20, 25, 2030. Oh, geez. 2010 should be here. Okay, let's just pretend Stirrup could space things out. So this is the year. Price of fancy car A. So I'm not going to pick what motor company we're talking about. Let's say we have a car company that we found that the price of the car is a linear regression as the years go on. Okay, we're good to about here. Why am I not good here and here? Well, again, it's extrapolation. The years 2025 and the years 2030 haven't existed yet, so nothing outside of it. But let's say this came to the point of, which is the Y-intercept, and let's say the year 2000 was the first year this car came out. First year of whatever particular car. This is the fancy car A. What does the Y-intercept mean in the context of this problem? Kind of already said it. It is extrapolation, but what does the Y-intercept mean in the context of this problem? Yeah. Now our first year the car came out, fancy car A came out, would have that price. So let's say the car was made in 2005. The car company started in 2005. So this is indeed extrapolation. We're not supposed to test it, but we could word it saying, if the automaker, being the automaker started in 2005, if they had started in the year 2000 making cars, our linear model would say that the price of the car in 2000 would be this. Though if this was our very first year that we're doing it, yes, it is extrapolation. We can predict a little bit off of extrapolation, but we can't necessarily trust it. Okay? There's times the Y-intercept won't make sense. Okay? The Y-intercept might not make sense if I had data plugged in and my line of best fit did this. What would be wrong with that value? Yeah. So that'd be like, if we were still doing the car thing, and that would be like saying, in year 0, 2000, the car was, they paid us to take the car. You know, if I were to look at, these are all prices, so like let's say this is the year 2020, the car was, $50,000. And then like let's say that this point here we knew that in the year 2007 the car was $30,000. And in the year 2000, the car was negative $120. Does it make sense that a car company would give you a car and pay you to have the car? I've definitely driven some cruddy cars in my years, but I don't think any of them have ever been free. Okay? So just realize sometimes the context. What about, so let's say we had an equation of 10 plus 30x. That's our line of best fit. Okay? And let's say I want to interpret the y-intercept and the slope. Now I have to come up with something that's going to go with that. Let's say this is x is going to be hours of tutoring, and so I know my price is going to be off a little bit. And then y is going to be price. Okay? So, what is my y-intercept first off? Yeah, so it's going to be 0, 10. So, what does that basically mean in the context of this problem? If we're talking about, you have this equation, 10 plus 30x. X is the number of hours. What does that really even mean? If I had 0 hours of tutoring, how much should I charge me?
It's like the base price.
Yeah, so sometimes you might say, it would be basically saying, for me to make a connection, they charge $10 up front. Okay. Now, it might be a bad analogy, but I mean, we all know that there's like, health clubs out there where they're going to charge you a $50 initiation fee because God forbid that someone actually had to type in your name, your phone number, and your email address, and that costs $50. But don't worry, it's only going to cost $10 a month after that. So there's a base price that happens. So if this was a tutoring company, if you called them and said, hey, we want to set this up, saying, okay, well, there's an initial $10 consultation, which means they're going to say, okay, what's your kid's name? They're Chris Stirrup. Okay. And what's their cell number? What's your name, parent, and what's your email? $10 on the price. What is the slope of this problem? What's the slope of this problem? Come on, Algebra 1, folks. 30. Now, slope, you want to have as a fraction, so make 30 a fraction, make it 30 over 1. So what does the slope mean in the context of this problem? X is the number of hours of tutoring.
Yeah, so every $30 you get 1 hour.
Yeah. Yeah, so you could say it'll cost me $30 for each hour of tutoring. You could say for each hour of tutoring I get, it's going to cost me an additional $30, something like that. So you're just kind of talking about what it means in the context. So if they give you a slope that is just a number, sometimes it'll be easier to put it over 1. It doesn't matter if you have a slope. If they give you some slope of 0.263, still put that over 1, because sometimes it'll make that easier to talk about, and you realize this is the change in y over the change in x. Okay? So, and this is just arbitrary, but just realize it is okay. I know in Algebra 1, they might have said this was, you can never have a decimal with as a fraction as well. It's kind of bad math. And I know there's some math teachers that say, no, you want to change it to 263 over 1,000. This is fine. It really is. Okay? What can you tell me if you had a correlation of 0? What can you guarantee? Here, let's draw this. What can you guarantee if this is our line of best fit? What can you guarantee if it's a correlation? Correlation is 0. What do you think? What? Yeah. So basically correlation is 0 means if I had this distance here, I'm going to have this distance here. Now that the two distances could be the sum of something. Correlation of 0 is really, really bad. There's nothing that was going to make our line of best fit happen. That means that if we had a graph, it basically looks like you took a fistful of mud and you threw it against the side of the garage. It splatters everywhere. There's not a line that goes with it. And yes, I realize you could stare at things saying, hey, it kind of looks like George Washington if you look at it sideways, or whatever thing. So let's see what specifically. Okay, so just trying to see what else there is. Yes.
Can you draw an example for number 13 on 2?
An outlier that increases the slope of the regression but decreases the correlation. So line of best fit. An outlier that increases the slope. So this would increase the slope, and it's going to decrease the correlation. That's basically all you're doing.
Okay, so it's just
So what this line would do is it's going to change it to this. It's going to move your line of best fit. So it's going to increase the slope because it's, that's a steeper line if we wanted to say that. But because it's so far out, this distance here versus this distance here, it's going to goof up our R value. It's going to make our R value closer to 0.
right. So then what about the number 12? Because the correlation is 0, but there's a distinct pattern. Would that be like the parabola?
Yeah. So if we were just plotted just data, and it looked like this.
So there would be a correlation of 0 with that.
The reason it would be a correlation of 0 is like if I did this,
There's no.
the distance of all the points above the line of best fit is equal to the distance of all the points below.
Okay.
Okay? All right. I think you're all ready. How many note cards do you need for this quiz? I don't know. There's some more up here if you need some more note cards. No, it's not going to be the pleasantry of group. So, Friday, multiple choice. I was planning Monday to have the written, but if truly all of you decide that your tummy's hurt, if your tummy's all hurt, I expect Reese's Peanut Butter Cups on Tuesday. Did you give me a whole bag of what? It's got to be a really big cut. I'm kidding. No. Okay, wheel on a pallet. Here you go, Mrs. Stirrup. Are you serious? Yeah. Cool. Let me stop this recording real quick.